I have a Craftsman EZT 15.540 turn mower that dies when the mower arms are moved from the neutral position or if the PTO switch is engaged.
Connect the meter lead wires to the wires in the clutch connector.
All are positive for continuity where it should be present and negative where it should not, I'm pretty sure. When I start the mower, it runs with no problems. I can start it without being in the seat, and getting out of the seat will not kill the engine. The brake switch is fine for continuity as well, but does not kill the engine in either position. The PTO clutch and both neutral switches will, though. The harness is in good condition. Should I suspect a relay?
Hello, and thank you for choosing JustAnswer. I'll be helping you today and am committed to providing clear and concise answers to your question. Let's double-check the seat switch, please. Try removing the switch and isolating the wires from one another. Be sure and look inside the connector. Some of these wiring harnesses have a shorting connector with a couple of spring clips that come together when the switch is removed to prevent someone from just removing the switch and defeating the safety feature. If it has those, separate them with a piece of wood, plastic, or paper for testing. The switch works the opposite of most switches. You want to break contact to let it run rather than close the contacts, which will cause the ignition to ground out and prevent spark. Let me know and we'll continue if this doesn't solve it. Site guidelines require that I post all troubleshooting steps or partial answers as answers, but this may not be the final answer. Additional troubleshooting may be required. So please hold off on rating until we determine the exact problem. If this doesn't solve it, or if you need additional assistance in applying this answer to your specific situation, please use the reply to expert link so we can continue the discussion.
This seat switch is a simple 2-wire type. It has continuity when depressed, none when it is released. I also have a new switch since I initially thought that was the problem. It does the same thing.
As long as the switch is good, next most common failure is the relays. You've got 2 on there, so I would check both, please. Here's how to do it. Testing, please keep me posted.
Both relays checked out okay.
Your PTO switch is the only other component we haven't talked about. If that's not it, then the most likely thing would be a short in the harness. I've attached a schematic so we can discuss further. What was the history leading up to this?
I'm starting to think it's in the harness somewhere. The PTO switch was fine when I tested it. Where do I start? Buying a test light?
You can do it with a test light if the circuit is energized. But a voltmeter gives a bit more flexibility since you can also look for a short to ground in an unenergized circuit by using the ohms readings and looking for low or no resistance instead of infinity. Doesn't take anything fancy. Even a $15 digital meter from the Walmart tools section will work for that. Using the schematic, isolate the wires from power, then with one lead grounded to the frame. I use the black one since I'm pretty procedural, and the other to the wire that's been isolated. Look for any continuity to ground. If you find continuity, that's the area that's shorted and need to be verified along its length.
When you say isolate from power, do you mean disconnect the battery?
Not just the battery, although unhooking the positive post is a good idea. But when you are looking for shorts like this, you want to effectively chop the circuit down, completely isolating one portion from what's both before it and after it. You want to disconnect it from power going in on the front side, and eliminate its path to ground on the back side. First, you want to eliminate the voltage since you cannot read resistance, ohms, on a live circuit and it can damage the meter. And second, since you've eliminated the path to ground, if you do see continuity, little or no resistance, that indicates you have a short in that stretch of wiring. Electrical can sometimes be a bit challenging since there's often no physical evidence. It has to be run down through the process of eliminating what it's not. You get rid of in why nots and it leaves you with what is. Did I explain that where it makes sense? Some things are easier to show than to tell.
Okay, that makes sense. I'll give it a try. Thanks.
Keep me posted, please. We'll work through it and figure this out.
I went through the harness today and found no shorts to ground. I checked and rechecked everything in the safety circuit and it's all negative for continuity, and then positive when I plug it back in. All the wiring was from the manufacturer, in looms and taped up. No rubbing, breakage, or melting. I am at a complete loss. This shouldn't be happening, but it is.
How did the diode at point 22 on the diagram check out?
I wasn't sure how to test the diode, but it kills the engine if you pull it out.
With the diode isolated and checking resistance, you should get continuity one direction and then not when you reverse the probes. The diode only allows current to travel one direction.
I checked the diode, and it performs as you described.
Then there has to be something overlooked, unfortunately. How did you check the PTO switch? Did you check only for continuity where it should be or also between contacts where it shouldn't?
I wish I knew what I was missing. What I don't see in the diagram is how the safety circuit grounds out the magneto. All of the switches seem to want continuity to keep the engine running, which is the opposite of what you were saying. I can jumper the neutral switches and it will stay running. What you were saying made more sense, that the magneto gets grounded when the circuit is completed. As far as the PTO, I checked for continuity when engaged, and it is continuous from the terminal 4 to terminal 1 and nowhere else. When disengaged, it is continuous from 3 to 9 and 4 to 7. The seat switch, even though it works right, will not kill the engine under any circumstances, but the PTO will kill it under any circumstances.
This shows the path the magneto get to ground. It can go either through the key switch or to the relay when energized. From what I see, they left out part of the schematic. Terminal 30 on the relay is common/ground. So that would be the alternate path. The way the manufacturer drew it, the only thing that relay would do is click, since it doesn't show 30 hooked anywhere and 87A isn't used. This one provides a path to ground through 30 when energized on 85. So the question is, how is this relay is not being energized? Since the PTO switch is doing it, we can surmise the start relay is working since it has a separate path. That leaves the seat relay, seat switch, and wiring between them as being the most likely. If you haven't, how about swapping the two relays and see if the symptoms change? Does the PTO still shut it down?
Okay, I swapped the relays, and the PTO no longer kills the engine. I switched it back, and it still doesn't kill it. I don't really understand what happened, but now none of the safety features work. The only thing that kills the engine is the key now. I am honestly fine with that after all this headache. Last question before I leave you alone. How do I test the PTO electric clutch to make sure it works? The deck and belts are disconnected due to a broken idler.
That is still sounding like the relay to me. But I really have to wonder if there isn't a short in the harness on that side that took it out. The best way to test the PTO clutch is to just jumper 12 VDC directly to the connector on the clutch. Disconnect it from the harness and jumper one of the terminals on the clutch to ground, then take your other jumper connected to the other terminal and apply 12 VDC plus when you're ready to test. Do it at a safe distance, especially if testing on a running engine. You should hear it energize and click the internal plate into place with the engine off, or it will start turning with the engine running. This basically does what the PTO switch would do, but you are applying voltage directly instead of through the harness. That's the way we test thin in the shop, quick and dirty. Another thing on the clutch is that some are adjustable, and this can make a difference. If you find slots and adjusting nuts, you can go in and check the gap between the two halves with a .015 feeler gauge. Make sure it's adjusted equally all the way around. Although it's a bit more involved, here's some other testing procedures on PTO clutches as well. This comes from Warner, who makes the majority of clutches for the outdoor power equipment industry. Warner info. 1. To measure the clutch coil resistance, turn off the engine and the PTO switch. A. Disconnect the clutch wire connection. B. Set the meter to check ohms. C. Connect the meter lead wires to the wires in the clutch connector. If the meter reads below 2.40 ohms or above 3.40 ohms, the clutch has failed and needs to be replaced. If the meter reads between 2.40 and 3.40 ohms, proceed to measuring clutch current draw. 2. Set the meter to check amps using the 10 amp scale. A. Connect one meter lead wire to one wire in the clutch connector and the other lead wire to the corresponding wire in the mating connector. B. Connect a short wire to the second wire in both connectors. C. Turn the PTO switch on. 3. If the meter reads below 3.5 amps, the problem would be in the electrical system leading to the clutch, such as the battery, a relay or a switch. 4. If the meter reads 3.5 amps or above, proceed to checking the air gap. A. Turn off the PTO. Locate the 3 windows or notches where the air gap is checked. C. Check the gap at 3 locations using a feeler gauge. D. The factory air gap settings is .010 to .025 inch. E. If the gap is incorrect, use a .017 feeler gauge and adjust the gap by tightening or loosening the 3 nuts on the clutch. 5. The electric clutch initially needs to be burnished before it is used by the owner. It is not always done at the factory and is the responsibility of the dealer or the customer. A. To properly burnish the clutch, run the engine at 50% throttle. B. Engage and disengage the clutch 5 times, 10 seconds on and 10 seconds off. C. Increase to 75% throttle. D. Engage and disengage the clutch 5 more times, 10 seconds on and 10 seconds off. 6. If you have a unit with an electric clutch that operates sporadically, check all wiring around the steering column going to the dash for fraying and shorts. A. Check the relays for proper connections. Newer models have inline relays to minimize vibration and reduce failure. B. You can remove the relays from the chassis of older models and tape them directly to the wiring harness. C. Check the PTO switch for proper connections. The red and blue wires might be reversed. The blue wire should be on top with the red wire directly below it. The brown wire should be on the opposite side.
If you have a home improvement or appliance question and want to chat with an expert now, visit justanswer.com/ythi.